in this module I want to talk about distributed denial of service. So let's check it out. The basic concept here is ultimately, no matter how you do it, to reduce someone's network traffic or availability, restrict legitimate access to something, or prevent an authorized user from getting access to something, or to flood your target with an overwhelming number of requests so that regular people or users cannot get access to what they need. So it's all rooted in the IAC triad availability section, okay? So basic concept here. Now the impact ultimately could result in a loss of goodwill, okay? Could disable a network, either in portion or completely unusable, or in worst case scenario, disable the organization completely unusable for a period of time, ultimately which would result in some sort of financial loss. So the major ways in which we can detect this are actively looking for signs of botnet style traffic, actively profile your networks, and if you can find signs of that, hopefully prevent it before it happens. But if you can't prevent it, well then your best effort is going to be to detect and correct as you go. Or change point analysis. Change point analysis is when an attack comes in, let's say it comes in from a particular IP address. Well, if that IP address changes or it goes to another network, you need to be able to profile, okay, well, my source is changing their way in. And so change point means changing the point in which they're coming in. So if you can profile that and see that they're bouncing around from network to network to network as they change IP addresses, well then you're tracking that change and ultimately you're tracking the source. So that's called change point analysis, okay? So distributed denial of service really has basically an architecture map into itself. So over here you have the happy attacker, and they create handlers or middlemen or middle computers, as we say, ultimately to find zombies or computers or people that don't know what they're doing to ultimately go attack a target. So the sole job of the attacker is to get a handful of handlers, which will then create as many zombies out there as we possibly can get. The more the merrier. I mean, this is where you really want to invite, 10 million of your closest friends to go attack a particular target, all right, through whatever technique. It could be some sort of software or an app in a store or something like that. But the attacker creates a handful of agents. The handlers distribute the zombies or give the instructions to the zombies, and then all of a sudden it's zombies rise, attack the target at a predetermined time, and then the target is now the sad target over here, which is getting an overwhelming number of requests coming in. So let's go ahead and look at the different techniques that make the target unhappy. One easy way is just to consume their bandwidth. Now, in the days where we only had 56K worth of traffic, you could easily just consume this with the simple ping command. Nowadays, with bandwidth on our side, it's a little bit harder to do bandwidth, but there's still several choke points out there. So bandwidth is just one technique. Other flooding techniques, the classic SYN flood, which is really a manipulation of the TCP three-way handshake. Detecting, from a defensive point of view, we would want to detect fraudulent or commonly reoccurring three-way handshakes and basically reset them or block them. But SYN flooding ultimately is a TCP protocol technique. If you can't do it from a penetration testing point of view, if you can't do it with SYN flooding, well, maybe you can switch your protocol down layer 3 ICMP and flood it with a large volume of ICMP traffic. When we ping something, we send a type 8 request out and we get a type 0 back, or an echo request and an echo reply. Well, you can strategically manipulate the ICMP packet, send it to your destination, overwhelm them with a large volume of them, particularly coming from a variety of sources. It gets a little bit harder to detect. And, well, not detect, it gets a little harder to defend against. It's pretty easy to detect because you're just not going to have service. UDP flooding, again, switch your protocol again. Okay, it could happen from a peer-to-peer network. You could target a particular application. Protocols like HTTP or PHP, they've been known to be extremely vulnerable. Think about everybody trying to check out of the online store at the same time. Something's got to give sooner or later. Or other techniques, permanent techniques like flashing. Right? Let's say that there's a website out there where you get some sort of update that it's critical and you must have, and then you download and install that, and now you have a piece of software on your system that's basically rendering it useless. Or, which is really, really close to the next example, which is breaking a system. Let's say that I want to get root access to my Android phone. Well, if I install the wrong update, that could ultimately turn that phone into basically a useless brick, because once the firmware is toast, how are you going to repair it? Okay? Or sabotage. In some cases physical, in other places through software. So now that we got the basics of denial of service, let's look at some of the countermeasures. Okay? You could simply absorb it. I call this the let's get punched in the face attack, right? You're just gonna stand there and just see how much you could take. Well, if you've got a robust network, you just might be able to absorb it, but again, I don't recommend that you get punched in the face attack. You could just allow your service to get degraded and maybe be able to go away after a time. One easy analogy in which you can think about here is think about your automobile, right? If there was a problem with your automobile, what could you do? How could you deal with it, right? You could just, absorb it, when your tire goes over a nail, okay, well, we'll just absorb it and keep driving. Or if your car starts degrading its service, it's not running right, you just keep driving, right? And let's hope it gets better. These are generally not good strategies. You could eventually take your car and shut it down, right, and get it towed to a shop. Networks are the same way. You could basically shut down your non-critical services and hope that there's just enough critical services to maintain being up and running. So you could shut down. You could try to actively find the botnets that are out there and neutralize them. You could deflect them, right? If an attack comes in, you deflect it and send the traffic somewhere else. If not, well, then you're probably going to have a conversation about forensics, which is probably the last technique that you'd want to apply, because if you're having a forensics conversation, one, it suggests criminal, and two, you're definitely in post-mortem at this time. Keep your software up to date, the latest and greatest software and patches. Good training awareness, don't allow people to install software that they don't trust from an unknown source, all of those best practices. Awareness. From a defensive point of view, you could just actively profile your traffic and see if there's any sort of botnet activity in terms of IP addresses or ports or websites, and perhaps block that in advance. You maybe detect spoofed addresses, since the attackers like to use middlemen or middle agents in between the attacker and the victim. Well, if you can analyze the traffic and see that there's a spoofed address, go ahead and block that. The most common way, in my opinion, is simply just really good inbound and outbound filtering, or ingress and egress filtering. Ingress meaning inbound, egress meaning outbound. You could use technologies like TCP intercept, which is a common implemented technology. You could use load balancers or some sort of throttling technique to limit how many requests could come in at a particular time. It's kind of like what we call queuing or quality of service. You could harden the systems, which is reducing your surface area of attack, so that if there's no surface area of attack or a very limited one, well, then you won't get infected with a zombie. You could use encryption, right? Things like WPA2. If you can protect what people can naturally see and keep certain people out of your networks through just good encryption, whether it be wireless or on the network. Encryption is a great countermeasure all in all. Or you can use dedicated hardware. And there's a variety of vendors out there that specialize in distributed denial of service. So all in all, this is what makes up the distributed denial of service. Organizations have suffered a large amount of financial loss. Ask any of the top victims of a distributed denial of service attack, and they'll tell you that this is not easy stuff to deal with, mostly because they get a lot of requests coming in from a lot of sources, and they just can't block or deal with this stuff fast enough. And that gives the penetration tester a couple advantages. One, because there's a lot of middlemen or middle computers in between the source and the destination, but also because you're rendering the network or organization useless. So you have to be careful when you use a lot of these botnet style tools, because in many cases the tools themselves also make you part of a botnet. So this is, if you're going to use these tools, disclaimer, you have to do it in an isolated environment so you can see what the tools are, but we have to act responsibly, because the last thing you want to do is learn distributed denial of service and then find yourself also a victim or a member of a botnet at the same time. So let's go ahead and take a hands-on approach.